Okay. Here's what you're doing today. You're going to take an equation. You're going to solve the equation. There's two types of equations. One is exponential, and one is logarithmic. Today is all exponential. Okay. Tomorrow is logarithms. Okay. So I'm going to break it into two parts. Exponential today, logarithms tomorrow. Then Thursday will be a worksheet on all of it. Okay. All right. So here's the deal. You've already done a little bit of this exponential stuff. Okay. So I'm going to give you some steps. Please copy this down and maybe just put it in the middle of somewhere in the middle here in your notes. And then I'm going to try to write you a couple examples as I do it. Okay. So how do we tackle exponential equations? Okay. This is what I would do right off the bat. Check for the same base. I should check for the same base. Okay. You've already done that. You did that on last week's quiz. You probably didn't know you were solving exponential equations, but you were. So here's an example of what I'm saying to you. 3 raise it to the x plus 2 equals 9. Raise it to the 4x. You did this problem last week on the quiz. Check for the same base. Do you have same base? 3 and 9, are they the same number? No, they're not. Okay, but wait a minute. If you don't have the same base, quickly try in your head. Can you possibly make these the same base? Yeah. Which one would you like to switch? The 9 I heard. Okay, so 9 is really what? 3 squared. There, you just made them the same base. 9 is 3 squared, and 3 is good. Leave 3 alone. But when you change 9 to 3 squared, it's still 9 raised to the what? 4x, right? Okay, now you got to know something about your exponent properties. When you take a power, you raise it to a power. What do you do to them? You multiply. Okay, so let's go over here and just say what? 3 to the x plus 2 equals 3 to the 8x. Good. There you go. And now this is what you did last week on your quiz. When your bases are the same, they call that the one-to-one property, which means what else has to be the same? Your exponents, don't they? So these are the same. The exponents have to be the same. So come on over here, solve it quick. You probably move the x over, right? 2 equals what? 7x. Now what? Divide by 7. The answer is 2, 7. Bingo. You got it. That's it. That was actually in lesson 3.2. It's also in lesson 3.4. Okay. So if you can make the bases the same, do it. If you have the same base, it's actually a very easy problem. At least I think it will be easy for you. Okay. That is step 1. Check to see if you have the same base. Step 2. What if you don't? What if you don't have the same base? Then do this. Isolate the base. Raised to a power of x. An example. What's an example of what I just said? Something like this. Get this all by itself right here. Isolate the base, and of course the base in an exponential problem is going to be raised to a power of x. In this case, 2x plus 1. Okay, so that's the first thing you'll do, and then the third thing, how do I solve for x? This is an exponential equation. You have to do the inverse operation. What? Okay, and you know, you're going into it quite deep. I just wanted you to say one thing. Take the log of both sides. That's what he's telling me to do, but he's telling me exactly how to do it. All I want you to write next is take the log of both sides. And when I say both sides, I mean both sides of your equation. Now, Alec, you said base 3, didn't you? Yeah. You know what? He's telling me to do base 3. I don't want to. I did what he said in period 4 this morning. I don't like that method. And it's hard for me to teach you something I don't like. And it works. Period 4 had no problem with it. They just did it. But then I got done and I went, I don't like this method. So period 5, I taught it the other way. So here's the other way. Take the log of both sides. Here's what I say. Base what? 10 or what? E. Why am I telling you base 10 or E? They're in your calculator. See, he's telling you base 3. And Alec, you're right. But the only problem with the way he's doing it is eventually, you know what he has to do? Eventually, he has to change it back to what? Base 10 or base E, because your calculator can handle it. And I think that's an extra step. Okay, but you can do that. 4. What's 4? Solve for what? What are we trying to solve for? What are we trying to solve for? X. Solve for X, period. Done. There's your steps. Now when we do our problems today, just keep looking at your steps. It's going to take you to the answer. There are 4 steps. All right, I'm ready. You ready? I think we're right here. Yeah. That's it. Okay. Take a look at that problem. You need to solve it. I'm going to rewrite it because you can't even see it. Okay, there you go. Talk to your neighbor. See what your neighbor's going to do. Try to solve it. Look at the 2. Can you factor out a 2, right? So when you factor out a 2, you say, when will this factor out a 2? When will this factor out a 2? When will this one be? There you go. Whatever. Right? 1. So when will this factor out a 2? If it doesn't have an X in it, can you have it? Okay. So that is not ever going to be 2 is always going to be 2. You can't change it unless it has an X attached to it. Then you can change it. Okay. Please tell me you did step 1. Step 1 said check to see if your bases are the same. Are your bases the same?
Yes.
Yes. So that means your exponents have to be what? They have to be what? The same number, right? So set them equal to each other. So when will 2x squared equal what? 4x minus 6. And you're supposed to be looking at that saying, that is a what equation? That's quadratic. How are you going to solve quadratic? Kind of heard somebody say it. Factor it, but you can't factor it until you set it equal to what? 0. Now, personally, I like my x squared term to be positive. I would jump the fence this way. I'd get the 0 over here and get that over there. Right? What'd you factor? How'd you factor it? Take out the GCF, which is what? 2. 2 comes out. X squared what? Plus 2x minus 3 equals 0, right? Okay. Then you factored the trinomial into what? X minus 1 plus 3 equals 0. So when will this times this be 0? You have 3 factors. When will this be 0, by the way? When 2 is 0? How do I make a 2 a 0? Guys, if it doesn't have an x with it, behind it, attached to it, the answer is when will it ever be 0? Never. That cannot be 0. But x minus 1 can be 0 when x is what? 1. This one when x is negative 3. There you go. Good? That's it. If the bases are the same, set the exponents equal to each other and just solve. Okay? If they look close, like that previous one I just did, 9 and 3, change the base yourself. Okay. Now what's going to happen now? It's not going to be quite as easy. 2 to the x, usually it's 2 to the x equals a number. Well, let's isolate this. Get this all by itself. So 2 to the x equals what? 14. Okay. And that's where we start. Get your base raised to the power of x by itself. Is there a possibility I could make that a power of 2? 2 to the third is 8. 2 to the fourth is 16. I missed it. I can't do it. So now, reading through your steps, where are we at? Well, no, 2 was isolate. I did the isolation. Take the log of what? Both sides. Okay, watch this. I'll do that. Take the log of 2 to the x. Take the log of 14. And it did say base 10 or base e. Always do base 10 unless your base is e. If your base is e, then do base e. But for right now, we'll just do base 10. So I'm in base what? 10. 10, right? Okay. Now, I have a calculator that can do this for me, so that's why I picked base 10. What I do right at this moment is I take the property from yesterday. The property said the exponent. Where can I put it? Out in front. So I can put it right there and then multiply it times what? Log of 2 equals log of what? 14. So what I did is I just used the property and stuck the exponent in front. Okay, you're solving for x. What's in your way? Multiplication by what number? Log of 2 is a number, right? So what are you going to do here to log of 2? What? Yeah, divide. Yeah, divide, because it's multiply, by log of 2. Okay, and of course log of 2 here just does what? Cancels out. X equals, here it comes, and now it's up to you guys to do this. It's not going to be perfect. We're going to go to the nearest thousands, okay? Log of 14. By the way, go like this with your calculator. Log of 14, wrap it up so it knows what to take the log of. Then hit your division sign. Log of 2. What is it? 3.807. Okay. This is what Alex said. Yes? By the way, your answers will always be really ugly, like 3.807. Are you sure you did this right? What if you typed it in wrong? What if you hit the wrong button? Guess what I'm going to tell you to do every time? Check it. Go back to the top. 3.807. I would do this if I were you. 2 raise it to the 3.807 minus 5. Better be what? Better be close to 9. Is it? Yes. You check it? Okay. Eddie said he checked it. And you should get like 8.99 or 9.000 something. Okay. Good? You okay? All right. Here we go. Do this one. I'm going to come down a little further. Got too much work. There you go. That's better. It's the same type of problem. It got a little more complicated. Just a little. Start by getting your base all by itself. What's next? Divide by 4. E to the what? 3x equals 2. Okay, now I've got my base all by itself. Once you get your base all by itself, now do what to both sides? Yeah, I was going to say, take the log of both sides, but Hunter beat me to it, and it's take the natural log. Because why? Why would you take the natural log? Because you've got base E right there, right? So you go what? Natural log of 2. Okay, now tell me what to do. Put the exponent where? Out front. So it becomes 3x times the natural log of E, right? Equals natural log of 2. Here's what I want to ask you right now. Do you guys know what this is? Do you know what the natural log of E is? You guys agree it's 1? So do you really need to divide by 1? You know what? You could have done this. At this point up here, you could have just done this. Base E, you could have just went like this. And the answer is what? It's just 3x. This number right here, guys, it's just 1. That's 1 times 3x, which is 3x equals natural log of 2. Now what? Divide by 3. Help. 2, 3, 1. Says Everett. Says Harry. Yeah? Okay. Guys, again, if I'm taking a test or quiz, I am not going to trust that answer. I could have messed up anywhere up there. I could have hit the wrong button. I would try that, put it in, see if you put it in, you better get what? You better get 11 or something really close to 11.
10.9.
You do? 7 what?
10.99.
10.99. Perfect. Okay. See that one? We'll talk about that one tomorrow. That's a tough one. I figured I want you to work. I want you to work today. I want you to learn how to do this. I don't want to hit this. It's too hard at this moment. Tomorrow you guys will be fine. Okay, here's the last slide. It's a special case problem. Why is it a special case? Oh, first of all, it doesn't say equal, so let's make it an equation. When will that equal 0? Okay, special case, why? Looks like something familiar, doesn't it? Looks kind of quadratic, doesn't it? It has that look. It's got a like e to the 2x, but that kind of looks like x squared. Minus 3, then e to the x, and then minus 28. This is something you have factored a million times. That has the same look. And the hardest part about that problem is simply going to be this. Can you answer this question? First term times first term must give you first term, e to the 2x. What is it? Is it e times e, guys? Is it e? Is that what it is? What is e times e? E squared. E times e is e to the first times e to the first. What do you do to those exponents? You add them. 1 plus 1 is what? E times E is E squared, not E to the 2x. E to the x times E to the x again.
No, just E.
Just E? Okay. All right, let's try it. Ready? E to the x times E to the first is E to the, add those numbers. What's x plus 1?
X plus 1.
X plus 1. Not E to the 2x. This is not it. E to the x, E to the x. Okay, let's try it. E to the x times E to the x is E to the x plus x. That's 1x plus 1x. What's that mean? 2x. We got it. There it is. That is the hardest part of the problem. E to the x times E to the x is E to the 2x. Now the other part is pretty simple. Give me two numbers. That multiply give me negative 28, but add up to negative 3. Say again. Minus 7 times plus 4. Got it. You now have factored that problem. Now solve it. Go get the answers. These are not the answers. These are the factors. Go get the answers. I'm not done. I'm half done. Oh, you finished. Yeah, but what I would do is I know when it's going to be 0 or when it's going to be 0. I'd set both. I'd set them both. I hope you guys understand this. This is only going to work if the first factor is 0 or the second factor is 0, right? That's the only way this is going to work. So you need to set your factors equal to what? 0. E to the x minus 7. When is it 0? E to the x plus 4. When is it 0? Well, the first one, e to the x, isolate it, equals 7, right? Now you just did a couple of these. How do you solve exponential equations? Take the log of both sides, but in this case, why wouldn't you take the natural log, right? Of e to the x equals the natural log of 7. Now that x can go out in front, so you can do this. But you sure don't have to, because what is the natural log of e? The natural log of e is 1. And 1 times x is x. So you're done. You just have to say x equals what? The natural log of 7. 1 point what? 945. Okay, good enough for me. The other one, ready? When is this going to be 0? Well, when e to the x is what? Negative 4. You take the natural log of e to the x equals natural log of negative 4. Again, this can happen right now. These are out. It's the natural log of negative 4. Why not? Can't take a log of a what? Negative number. Okay, so basically there's no solution because you can't take the log of a negative number. Do you guys know why you can't take the log of a negative number? Hey, think about the graph. You guys should all know the graph of a log equation does this, right? Isn't this the graph of a log? It's always 1, 0. And then in your case, your base what? Your base E. So E would get what answer? E would get 1. Now, watch this. Why does 7 get an answer? Because 7 is right here. Here's 7. It gets an answer. It's right there. So why does negative 4 not get an answer?
Negative 4's on this.
Because negative 4 is right here. Go up. Go down. Where do you hit the graph? You don't. That's why negatives don't get answers. Because the graph never goes on the negative side. So, anytime you plug in a negative, you get no answer. What about 0? Would you get an answer for 0? Put 0 in, guys. Go down. Are you going to hit this thing? No, because 0 is the what? It's the asymptote. It's not going to get an answer. So when do you get answers? When you plug what in? Only positives. That's it. Okay. I'm done. You guys? You got 15 minutes. Nah, shoot. You got 10, 12 minutes. But you could probably get a third done. Just get going. It isn't that bad. It's a pretty nice assignment, especially because you're only doing one thing, exponential equations. Okay? All right, go.